So today I'm talking about functions, specifically operations of functions and composition of functions. We're going to start with operations with functions. So it's the four basic operations: addition, subtraction, multiplication, and division. But we're going to do them with functions. So a couple of notes, the bullet points that I had added to my notes, which tells me it was to answer questions from homework whenever students were asking in previous years. The first one is, for each new function, the domain consists of the values of x common to the domains of f and g of x, or the original two functions. That's assuming you're working with f and g of x. So whenever you get your new function, its domain is the overlapping of the original two functions. So you have to find the original ones, and then from that, decide what your new domain is. And then the domain of the quotient function, so if you are working with the quotient function, that one is further restricted by excluding any values that would make the new denominator equal to 0. So you have to, for the quotient, consider the original domain of your two original functions, and then a third restriction would be anything that makes the new denominator equal to 0. All right, so we're going to just do some examples, one example of each operation. So if we're given that f of x equals x squared plus 4x, g of x equals the square root of x plus 2, and the h of x equals 3x minus 5. Those are the three functions we're going to use for these examples. Do the operation and find its domain. So first we're going to do f plus g of x. So we're going to add f and g. So this starts with f. So we're going to write the f function, and then we're going to add the g function to it. So f is x squared plus 4x. And then we're going to add the g function, which is the square root of x plus 2. So we took the first one, and then we added the second one to it. And then you look to see if you can simplify that. For this one, we cannot simplify that. There's nothing, no like terms, there's nothing that we need to do with that. So that's it. That is f plus g of x. And find its domain. Okay, so the domain of f of x, you have to look at that first. So f of x, x squared plus 4x. That was a quadratic. If it helps to think about what the graph of a quadratic looks like, there it is. So domain of that would be all real numbers. So the domain of f of x is all real numbers. And we need to look at the domain of g of x. So then we look at g of x, that is the square root of x plus 2. That function would look kind of like that. So we can see, looking at the domain left to right, there is a restriction, because anything that would make what's inside the radical equal to less than 0 would have to be restricted, because it would give you an imaginary number, right? So anything that makes this less than 0 would be restricted, because that would be imaginary. So we would take the function square root of x plus 2. It must be greater than or equal to 0. So then we solve it. We square both sides. 0 squared is 0. So x plus 2 must be greater than or equal to 0. So subtract the 2. So x must be greater than or equal to negative 2. So this was to find the domain of g of x. So we know x must be greater than or equal to negative 2. Greater than or equal to means it's a bracket. And the -2 is the smallest thing it can be. If it's anything smaller, it's going to give us something less than 0. So -2 to infinity. That's the domain of g of x. So here we have domain of f of x. Here we have the domain of g of x. So if we want the domain of f plus g of x, according to this first bullet point, for the new function, the domain consists of the values of x that are common to the domain of f and g. So f of x includes all values, but g of x only includes from -2 to infinity. So the ones that are common are the g of x domain. So that would be the combined domain. So we have f plus g of x, and we have the domain of f plus g of x. All right, so that's addition. We're also going to do this with subtraction. This one's going to be f minus h of x. So again, we start with the f function. And then we're going to subtract the h function. So h is 3x minus 5. Now, what is wrong with what I've written?
The sign of the function.
Since we're subtracting, we should put the second function in parentheses because we need to subtract the entire thing, not just the first term. So if you're subtracting, you need to put it in parentheses and then simplify it. So this negative then will go to the 3x and the -5. So now we have x squared plus 4x minus 3x plus 5. And then from here, we have two different x terms in the middle. So we're going to combine the like terms. 4x minus 3x is x. So this is x squared plus x plus 5. So there's f minus h of x. And we still need to state the domain. So we need to look at the domain of f. Which we've already done that. It didn't change. Domain of f of x is all real numbers. And we need to look at the domain of h of x. We haven't looked at that one yet. So we go to h of x. It is 3x minus 5. That is linear. Y equals mx plus b form, that's slope-intercept form. So domain of a line is -infinity to infinity, or all real numbers. So since they have everything in common, that tells us that the domain of f minus h of x is also all real numbers. So these two imply that the domain of f minus h of x is also all real numbers. And if you like to write -infinity to infinity, that's fine. It doesn't matter. However you write it. All right, so we did addition, we did subtraction. So next is multiplication. F times h of x. So we're going to do the f function and multiply it by the h function. So in parentheses, I'm going to write the f function, x squared plus 4x. And then in parentheses, I'm going to write the h function, 3x minus 5. So this was f times h. So we're going to multiply them together. So we need to simplify, so that means we have to multiply them. I'm going to use FOIL. If you want to use whatever method you use, that's fine. They're all essentially the same thing. So with FOIL, I say the first two terms, multiply those. That gives me 3x to the third. And then I do the outside terms. Negative 5 times x squared is negative 5x squared. Then I do the inside terms. Gives me positive 12x squared. And then I do the last two terms. Gives me negative 20x. When I FOIL, I end up with like terms in the middle. So I have negative 5x squared plus 12x squared is positive 7x squared. So this is 3x to the third plus 7x squared minus 20x. That is my f times h of x. And then I want to look at the domain. So again, I'm comparing the domain of f of x, which was all real numbers, and the domain of h of x, which is all real numbers. So the domain of f times h of x is also all real numbers. So it's the same that I just did up here. So I can just write it again as the domain of f times h of x equals all real numbers. Because it's the same thing as that. And then the fourth operation is h divided by f. So we're going to do h over f of x. And the h is on the top, so 3x minus 5 on top. And the f is on the bottom, so x squared plus 4x is on the bottom. And there's nothing I can do to simplify that. So we're done with writing the function. That is h divided by f of x. But we do still need to find the domain. Even though these are the same functions we just did on the previous two examples. So we know that the domain of f of x is still all real numbers. And we know that the domain of h of x is all real numbers. But that bullet point up at the top of the page, the second one, the domain of the quotient function is further restricted by excluding any values that would make the new denominator equal to 0. So when writing the domain for a quotient, you have to look at restrictions from the original two functions, plus you have to make sure your new denominator does not equal 0. So we need to take this denominator x squared plus 4x, and set it equal to 0 because we cannot divide by 0. If 0 is in the denominator, it's dividing by 0, and we cannot do that. So I'm going to factor and solve this. That is a GCF of x, and that leaves x plus 4 equal to 0. So I set x equal to 0, and I set x plus 4 equal to 0. So that tells me that x cannot equal 0, and x cannot equal negative 4. Those are my domain restrictions, because if this denominator, if the x value is 0, it gives me a 0. If the x value is negative 4, it also gives me a 0. So now I can write my domain of h over f of x. It's going to be all real numbers, comma, but x cannot equal 0 or negative 4.